Hello there. It's a pleasure to share this quiet corner of the evening with you. The house has slowed. A small circle of lamplight keeps watch, and the day feels a few rooms away. Tonight, we lean towards Saturn, the ringed wonder that seems, by tidy rules, not to make sense at all. A giant that behaves like a whisper. Veils of ice that look too delicate to last, yet they linger, gleaming like frost in soft gold. The more we learn, the more it feels like a beautiful contradiction. If you'd like, tell me where you're listening from, what the night looks like out your window. I love knowing where these calm minutes find you. And if these gentle explorations keep you company, a quiet like and subscribe is a kindness only when it feels right. For those already here each week, thank you. Your steady presence keeps this little harbor lit. I do hope our visit doesn't become so fascinating that it steals your sleep, but if it does, may tomorrow arrive with one more bright thread of wonder in your pocket. Now, let the evening be enough. Saturn is waiting, and we'll begin together, unhurried and warm. Before we step closer, keep a small question cupped in your hands. If a world as improbable as Saturn can be real, what does that say softly about the universe that made it? Breathe and picture a slow drift through space, the kind of stillness that asks nothing of you. Ahead, a pale lantern gathers Saturn, ringed as if the night exhaled a scarf of frost and let it hang in the dark, waiting for us to arrive without hurry. Starlight brushes the countless particles that circle the planet, and they glimmer as though the cosmos had been dusted with crushed ice. You approach without hurry, as if invited to take your time. What first looked like a single, polished halo begins to separate into bands of brightness and shadow, broad arcs poured across blackness, graceful and calm. From far away, the rings seem smooth, almost solid. Up close, the illusion loosens. The halo resolves into an intricate gathering of icy fragments, each keeping its own small path. Some are no bigger than grains of sand. Some have the sturdy presence of a house. Together they make a luminous ribbon that circles Saturn in a silent, perpetual ballet. Skimming the edge of the ring plane is like drifting through frozen lace, soft haze all around, lit by a distant sun. That sunlight has traveled more than 1 billion kilometers to be here. It arrives gentler than the light we know on Earth, yet the rings answer it with quiet brilliance, as though cold has polished every face. And for all their breathtaking span, the rings are astonishingly thin. Spread them around Earth, and their breadth would reach toward the moon's path, yet their thickness would be only that of a few tall buildings, stacked one upon another, a sheet of paper stretched across a football field. As your gaze settles, 3 broad bands come forward. Closest to the planet lies the C ring, faint and ghost-like, letting much of the pale light slip through. Beyond it is the B ring, the brightest and most opaque, dense ice reflecting sunlight like a frosted mirror. Farther out sweeps the A ring, broader, a little more translucent, still bright enough to hold the eye. Between the A and B rings rests a darkened boundary called the Cassini division, not empty, but sparse enough to feel like a deep breath between 2 bright strokes of ice. These are the great visible rings, C, B, and A, each with its own texture and tone. Fainter wisps, narrow ringlets, and soft halos reach beyond them, but they reveal themselves only when curiosity leans closer. For this gentle moment, the 3 main bands are enough to sketch the architecture without crowding the senses. The particles themselves are mostly water ice, often pure enough to gleam in the far light. Some carry a dusting of darker material, tiny flecks of cosmic debris and long-traveled organics that have settled over time. That detail can wait. It is enough to feel that the rings are a tapestry of frozen fragments, circling in patient order. Drifting with them, you notice how peacefully they travel. There is no clatter. Collisions do happen, but space spreads time thin. Meetings are more like nudges than blows, small exchanges of motion before each piece resumes its path. This continual, gentle negotiation keeps the ring faces smooth to a distant eye, like a lake whose ripples cancel one another and leave only sheen. Imagine for a moment holding one of these fragments. If such a thing were possible, it would resemble a snowball, cold, compact, glistening. Some pieces are fluffy and loosely packed. Others are clean, solid ice. The whole scene feels familiar and otherworldly at once, as though you were standing inside a snowstorm of crystal that never melts. Light is the ring's favorite companion. Each fragment scatters and reflects sunlight in its own way, and together they compose a slow, shifting play of brightness. When the sun stands behind the rings, they glow like frosted glass, lifted to a window translucent, veiled. When sunlight falls from the front, they dazzle like fresh snow. Move your point of view, and the theater changes again. The arcs brighten and fade, edges sharpen and soften. It is nature's most quiet light show. Just above the rings, the planet begins to fill your view. There is no hard surface, only the high blanket of clouds, smooth, banded creams and gentle golds, with muted gray threaded between. Shadows from the rings slide across those clouds, long arcs laid over the atmosphere. The effect is soothing, as if day and night were feathered into one canvas. The rings do not simply encircle Saturn, they paint it, laying veils of moving light. Seen like this, Saturn feels timeless, a figure that has always worn its icy adornment. From this soft vantage, it's easy to imagine the rings as ancient and unchanging, perfect, complete, but appearances in space are patient tricksters. The rings keep their secrets quietly, inviting careful attention. They look everlasting. Their story is more delicate. Hold that thought close. How did something so thin and intricate take shape around something so immense? It feels almost too graceful for such a giant. The hint of an answer begins with what Saturn is made of, and with how a careful balance allows fragility to live beside force. You may have heard the playful claim that Saturn is so light it would float on water. It's the kind of image that lodges in memory, a beach ball planet bobbing in a cosmic tub. Charming, but it asks for a gentle untying. The notion comes from average density, the amount of mass tucked into a certain volume. Saturn's is lower than water. On paper, the planet would float. In reality, there is no ocean vast enough, and a gas giant has no shell to rest on a surface. The gravity involved would warp any imaginary basin long before Saturn could show off its buoyancy, and the planet itself would not remain politely intact. So the picture is better held as a metaphor, a reminder that Saturn's substance is light, not a promise that it could lounge in a bath. Most of that substance is hydrogen and helium, the universe's lightest pair, the same foundation that builds the stars. On Earth, we meet helium in party balloons and hydrogen in chemistry, but here they become the fabric of a world. Picture a planet woven from airy threads, and the low density begins to make sense. Yet, light does not mean weak, nor does it mean hollow. Scale does its own kind of magic. If Earth were a cherry tomato, Saturn would be a beach ball beside it. The materials are lighter, yes, but there is so much more of them. The result is mass, immense mass. Saturn is more than 90 times as massive as Earth, a world made of the universe's lightest stuff, and yet it carries a weight of presence our smaller planet cannot match. To feel this contrast, imagine holding two objects. In one hand, a huge marshmallow, big, fluffy, easy to press. In the other, a small bowling ball, compact, startlingly heavy. Saturn is the marshmallow in that picture, enormous, made of light ingredients. Earth is the bowling ball, smaller, dense with iron and rock. Density tells you about the material. Mass tells you about the pull. Gravity listens to mass, not to texture, not to fluff, but to how much matter is gathered. Saturn gathers a great deal. If you could stand at the level of its high clouds, the planet's pull would feel a little stronger than Earth's. That surprises people who hear low density and imagine feather-light gravity. Another Saturn paradox: light in composition, powerful in hold. Inside, the planet is layered, not like a rock with a crust, but like deep weather. The outer reaches are hydrogen and helium clouds. Descend, and the gas thickens. Under tremendous pressure, it blurs toward liquid. Deeper still, physicists expect a strange phase called metallic hydrogen. Hydrogen, squeezed so tightly, it conducts electricity like a metal, glimmering in ideas more than in sight. Beneath that, most models point to a dense core made of heavier ingredients: rock, metal, ices, mixed into a compact center. No craft can survive to see that core directly. The pressure would end any journey long before it arrived. Instead, we learn by inference, by the wobble of the planet, by the behavior of rings, by how gravity tugs on visiting spacecraft. And the picture that forms is not a single hard truth, but a confident outline, sketched by many careful measurements. And still no firm ground. You cannot stand on Saturn. A fall through those clouds would be a passage from thin to thick, from hazy to heavy, from gas toward liquid, until heat and pressure close the book. It is a world defined by gradual change, gentle at the top, crushing deep down. Another reason Saturn looks the way it does is speed. The planet spins quickly, turning once in a little more than 10 Earth hours, remarkable for something so large. That rotation tugs the equator outward and flattens the poles, making an oblate spheroid, wider around the waist than from top to bottom. Earth does this too, but softly. Saturn's fluid nature lets the bulge show. The image is simple: a ball of dough spun by a baker. The dough stretches and grows wide where it whirls fastest. On Saturn, that shape helps set the wind patterns, the long, gentle bands that wrap the planet, and contributes to the soft striping we see from far away. The planet has been sculpted by motion, shaped by the forces that never stop. And Saturn's gravity is not content to end at the cloud tops. It reaches outward, arranging a miniature celestial neighborhood, dozens of moons, a wide ring system, and countless smaller pieces, all answering to its pull. Think of a large, quiet creature that seems soft and slow, yet holds an entire clearing in balance simply by being there. Saturn carries that kind of presence, serene on the surface, commanding underneath. That is part of its charm, a world made of light elements, guiding an orchestra of ice and stone. Our everyday habits teach us that big things are heavy and light things are fragile. Saturn asks us to hold two truths at once: light in composition, heavy in influence. It could float in theory. In practice, it anchors moons, shapes rings, and orders space around it. From certain angles, the ring plane turns delicate beyond belief. Seen edge-on, the whole sweep narrows to a knife-thin line that can nearly vanish against space. Tilt the view, and the breadth returns, bands unfolding like pages. As Saturn moves around the Sun, the ring angle changes, and the shadows they cast grow long, then short, then long again. Return to that dark boundary, the Cassini division. It is not a void but a pause, a place where fewer particles stray, a quiet lane between two bright avenues of ice. Think of it as a deep breath set between bold brushstrokes. Even here, nothing is truly empty. Scale keeps tugging at the mind. If the main rings were draped around Earth, their spread would reach toward the moon's path, while their height would remain so slight that a city skyline could overtop it, paper across a field. The calm you sense is not an absence of motion, but the harmony of it. Because most particles share similar paths, their speeds nearly match. Meetings are more like slow dances than collisions. A nudge, a traded bit of motion, then back to the circle. Over time, it smooths the face to a distant eye. Light writes quiet poetry on those faces. With the sun behind them, the rings turn to silver gauze. With the sun in front, they blaze like fresh snow. Move a little, and the script changes edges, sharpen, then soften. Near the bright expanse, small moons keep company, tucking in edges and smoothing gaps the way careful hands neaten a ribbon. Nothing hurries, yet everything moves. Look back to the planet. Cream bands flow like rivers of air, storms round into pale ovals, and fine textures braid the zones like threads of silk. Long ring shadows cross it all, tying day to night with patient lines. That speed matters a day, a little over 10 hours, swells the equator and draws the poles in, shaping a globe wider at the waist than tip to tip. Inside, pressure gathers until names blur. Gas presses toward liquid. Deeper still, hydrogen may behave like metal, carrying current as if it were wire. We cannot watch it directly, so we listen to the gentle wobble felt by passing craft, to faint tugs measured over equator and pole. Bit by bit, a picture appears, not a photograph, but a drawing, retraced until it holds, inviting us to read what weight and power truly mean here. Saturn, by that quiet picture, asks us to loosen certain habits of thought and reconsider what light, heavy, strong, and delicate really say. A world made mostly of hydrogen and helium should sound airy on paper, and yet the authority it holds is undeniable. Its gravity steadies the rings, tends their edges, and conducts a family of moons with the patience of a long-lived orchestra. From a planet among the least dense in our neighborhood, a lantern feathered at the edges, comes a poise that keeps an entire system in time. It feels like a paradox until you sit with it. Light in substance, immense in scale, graceful in posture, influential far beyond the cloud tops. Saturn wears contradiction like a well-fitted cloak, soft to the eye, firm in presence, perfectly at home in the tapestry of our solar system. Imagine hovering just above the high clouds. The first thing that reaches you is the calm of the patterning. Soft bands wrap the curve, pale stripes of cream, butterscotch, and muted gray. They run all the way around, as if a careful hand had brushed the planet in even strokes. From a distance, the whole globe looks dreamlike, a sphere dressed in layered silk. Beneath that quiet skin, motion never sleeps. Saturn is a world of winds, swift, organized, and astonishingly steady. Long ribbons of air, the jet streams, race around the planet from west to east, then east to west, trading lanes as they circle. Where these bands touch, the atmosphere curls and braids, and the boundaries stitch themselves into patterns that reward a lingering gaze. Near the equator, speeds can climb beyond 1,000 kilometers per hour. On Earth, that would be a disaster. Here, it is simply part of the daily rhythm. One reason the sky moves this way is the speed of the world itself. Saturn turns once in a little more than 10 Earth hours. Imagine our own planet spinning nearly twice as fast and the weather it would brew. On Saturn, that swift rotation, spread over vast size, invites the Coriolis effect to draw sweeping curves in the air. The same principle that nudges hurricanes and trade winds on Earth becomes grander here, painting multiple jet streams and broad, beautifully banded systems that span from horizon to horizon. Those clouds come in layers, each with its own gentle character. The highest deck we can see is made mostly of ammonia ice, lending the planet its pale, creamy veil. Beneath it sits a layer rich in ammonium hydrosulfide, a sulfur-bearing frost that warms the palate toward beige and soft yellow. Deeper still are great banks of water cloud, more like the clouds we know at home, though the world around them is unlike anything familiar. Think of a glass trifle assembled with care, tiers set one above the other, each adding a faint flavor to the whole. Because each layer answers differently to temperature, pressure, and the steady push of the winds, the patterns shift and blend over time. Edges melt into one another. If Jupiter is sometimes an oil painting, bold swirls, vivid spots, sharp contrasts, Saturn is a watercolor, its tones dissolving softly, its transitions feathered and slow, quieter, yes, no less captivating. Quiet does not mean empty of drama. Here, storms can grow to planetary scale, stretching across thousands of kilometers, at times circling the globe in bright, looping bands. Some last for months, some persist for years, rolling along the jet streams and changing shape as they go. There is a recurring visitor with an old, gentle name, the Great White Spot. It tends to appear roughly once each Saturnian year, about 29 one-off Earth years, part of a long seasonal rhythm. When it rises, billowing towers of clouds stand out against the usual calm, bright enough to be noticed by telescopes on Earth as pale smudges on a muted face. Inside such tempests, lightning cracks with uncommon strength, bursts that can be hundreds of times more energetic than a typical bolt on Earth. In Saturn's thick, layered sky, that electricity glows through haze and ice and cloud, so the storm does not just flash, it seems to pulse, as though the atmosphere itself were breathing light. Even so, most of the time the weather prefers order to chaos. Flows organize into great, sweeping lanes. Storms fold themselves into the broader pattern rather than tearing it apart. The winds, for all their speed, behave like good neighbors. They share a rhythm, they merge, they part, and still, the soft banding remains, the signature most of us recognize at a glance. Color tells this story quietly. No loud crimsons or hard oranges shout for attention, as they sometimes do on Jupiter. Instead, dawn shades pale gold, gentle cream, light gray, with an occasional wash of pearl. The palette shifts as the seasons turn, and the chemistry ebbs and flows, yet the feeling stays the same, reserved elegance, a wardrobe chosen for a world that prefers to whisper. Underneath the beauty, the winds revealed purpose. From equator to pole, layer by layer, the atmosphere converts sunlight, internal heat, and rotation into motion that can endure for decades. It is fair to call the upper sky an engine, though a very quiet one, constant, efficient, tuned by the planet's shape and spin. When we picture wind, we borrow from Earth, trees shaking, water roughening, leaves rushing down a street. the hiss that puts a sound to movement. None of that applies here. There are no branches to bend, no seas to comb, no ground to feel the gust. The winds we speak of are motions of gas and cloud, gliding and streaming through an air ocean with no shore. Float beside them, and you would hear almost nothing. The motion is visible, not audible bands sliding past like silk ribbons in a slow, steady current. That is Saturn's special spell. Extraordinary speed paired with profound quiet. Scale is magnified, sound is restrained. Even the great tempests fold into harmony, as if the whole planet were an orchestra, tuned so well that every loud note lands as part of the music. Ribbons for strings, storms for percussion, long-lived flows for the low woodwinds. The song moves too slowly and softly for any ear, but it goes on year after year, season after season. While the world looks gentle from afar, the atmosphere carries energy, motion, and durable patterns. The soft stripes and drifting gyres tell of a planet shaped not by stillness, but by perpetual movement, a place where calm is woven through speed. It is a lesson in how power doesn't need sharp edges and dynamism doesn't require disorder. Hold your gaze near the top of the map, and another wonder arrives, unexpected, precise, and utterly serene. At Saturn's North Pole lies a storm that refused the usual shapes, not a circle, not a spiral. A hexagon, 6 clean sides meeting at crisp angles, stretched across a distance so large that each edge could swallow continents. It turns with the planet, unhurried and exact, as if the globe had chosen a geometric crown. From above, the sight is disarming. 6 walls of cloud, smooth as if drafted with a ruler, enclosing a whirl that rotates with patient resolve. Most storms in our solar system round themselves into ovals because that is the easy shape for rotating fluids. Here, movement has folded itself into symmetry, and the result looks like a calm piece of architecture set in air. When Voyager sent back the first images in the early 1980 seconds, more than a few people blinked. The figure was so regular, so unlike anything we had seen on another world, that suspicion flickered. A camera trick? A processing artifact? The whimsical fringe even floated ideas of a built structure. Better data answered with a more satisfying truth. The hexagon is natural, an expression of physics on a grand canvas, sketched by the motion of Saturn's atmosphere. To feel how such a thing can arise, think of waves, not the seas, but the kind that live in air and cloud. Spinning fluids tend to settle into patterns, and sometimes those patterns break symmetry in lovely ways. Around Saturn's North Pole, a fast, steady jet stream circles like a river in a deep, round channel. Under just so conditions, that current doesn't hold to a smooth ring. It develops a standing wave, a shape that seems to stay in place even while the medium itself keeps moving. You can make a small version with a jump rope. Shake it just right, and you'll see humps that stand still even as the rope vibrates. Now imagine joining the ends of the rope to make a loop and continuing the rhythm. Depending on how you drive it, the loop can settle into 2 bulges, or 3, or 4, or 6. Saturn's flow has chosen 6. The standing wave, guided and stabilized by the planet's rotation, locks the fast current into a hexagon. The idea isn't without cousins here on Earth. Sound waves can draw geometry on vibrating plates, rotating fluids chilled and spun in the lab, sometimes settle into polygons. Researchers have reproduced ring-shaped currents with corners on small scales, showing that nature can indeed carve shapes with edges from the smoothest of materials, given the right push and pull. This is no flat picture painted on the cloud tops. The hexagon has depth. It reaches downward into the atmosphere and rises into the stratosphere, an airy column with 6 sides, turning like a patient chimney of weather. Each side is a segment of the high-speed current. Together, they frame the polygon as it circles the pole. In the center, a darker eye often turns as well, a cyclone nested within the geometry, as if the shape were a frame for a quieter whirl. Its look changes with the planet's long seasons. In some views, the region wears pale gold and tan. In others, especially when sunlight returns after years of winter night, a bluish cast shows through. Saturn's year lasts nearly 30 Earth years, so the North Pole spends long stretches tipped away from the sun, and then long stretches tipped toward it. As light angle and chemistry change, the colors shift. The hexagon persists. Longevity is part of the astonishment. Most storms on giant planets twist, breathe, and fade. Jupiter's Great Red Spot holds on for centuries but changes its outline with time. Saturn's hexagon keeps its geometry with almost stubborn loyalty. It turns with the planet like a slow clock, season after season, decade after decade, adjusting subtly but rarely abandoning the 6-sided signature that makes it so arresting. What holds it steady is a balance of simple names in a complex braid, rotation quick enough to shape the flow, a jet stream with just so speed and width, layers stacked so the wave can anchor and last. Change any ingredient, and the pattern would wobble or fray. Here, the recipe aligns, the air streams, the wave settles, and the geometry clicks into place. Because the figure is so exact, imaginations wander toward intention, symbols, messages, invisible engineers. But the kinder truth needs no hidden hand. The hexagon is order crystallizing out of motion when the rules are right. The universe's fondness for pattern written large and quiet at a pole few eyes will ever see. If such a storm crowned Earth, we would never stop watching. On Saturn, it simply turns through years-long dawns and dusks, through winter dark and summer glow, reminding us that symmetry can bloom from swirl, that calm can rise from speed, and that a giant made of light elements can still host shapes that feel carved and soothing to behold. And if you want a picture your hands can hold, think of a flame. A candle in a still room wavers at the faintest breath. Then the air settles, and for a rare stretch, the flame becomes a perfect teardrop, so steady it looks sculpted. Saturn's North Pole keeps a moment like that, frozen into weather. From winds that should curl and scatter, a shape holds. 6 equal sides, 6 clean edges, 6 rivers of air meeting like corners in a quiet hall. Geometry written in cloud and light snowflake logic, honeycomb calm spread across a polar sky on a world so large you could set Earth inside the circle more than once and still not touch the rim. The mind expects chaos when it hears storm, yet the pole offers precision. It expects swirls and circles from a spinning ocean of gas, yet these straight lines meet with almost architectural confidence. Nothing about it is artificial. It doesn't ask for secret engineers or hidden messages. It is simply what moving air can decide to do when the conditions balance just right. Order rising from motion, a stillness drawn onto speed, a sculpture maintained by wind. There is quiet poetry in that, at the top of a giant. Symmetry has taken a seat and stayed there for decades, turning unhurried beneath pale sunlight. Let that image keep you company, a hexagon that keeps time like a patient clock, As the seasons drift by, its edges soften and sharpen with light. Its form remains faithful to the dance that sustains it. It reminds us that nature's handwriting includes neat corners as well as curves, and that the universe saves some of its loveliest surprises for places where no one is watching in person. Time itself stretches differently there. One Saturnian year, one full loop around the sun, lasts almost 29.5 Earth years. Each season lingers for more than 7 Earth years, so winter is not a brief inconvenience, and summer is not a sprint. They arrive as long moods that move at the pace of glaciers. Saturn leans on its axis by about 26-27 degrees, close to Earth's 23½ So the cause of the seasons feels familiar, even if the tempo does not. At times, the north tips toward the sun and basks in extended daylight. At other times, the south accepts that glow. Between them come quieter intervals, when neither hemisphere is favored and the light is more balanced. If you could watch long enough for an entire Saturnian year to unfold, you would see the planet's face change with a patience that feels ceremonial. Much of the spectacle is written not only in color but in shadow. The rings are thin and wide, like a flat ribbon laid across space, and they cast great sweeping shadows that glide over the cloud tops. During solstices, those far-leaning moments when one hemisphere is tipped most toward or away from the sun, the shadows stretch dramatically across the atmosphere. Imagine dusk moving over a landscape, except the landscape is a gas giant, and the shadows belong to ice suspended high above. Picture a twilight that refuses to hurry. At one solstice, the north is glazed with long daylight, while the south lounges in a drawn-out evening. Half a Saturnian year later, 15 Earth years, the roles reverse. Sunrise and sunset take on new meaning when a single spring lasts around 7 years. Dawn arrives not with a rush, but as a slow tide of brightness, a morning that thickens across seasons. Summer becomes a long, steady glow, more like a breath held and released with care than a burst of heat. Then come the equinoxes, 2 moments in each long year when sunlight strikes the ring plane edge-on. From certain angles, the rings seem to thin to a line so slender they almost disappear, because the sun no longer illuminates their broad faces but touches only their knife edge. Shadows fade to nearly nothing, and the planet's cloud tops glow evenly, as if veils had been lifted. Oddly, this is when small secrets become easier to read. Tiny warps or ripples in the ring plane can cast tall, delicate shadows, revealing little heights and bends that bright reflections usually hide. These edge-lit views are rare, separated by nearly 15 Earth years. They feel like the hush between long verses in a song. Solstices tell a different story. When one hemisphere tilts most directly toward the sun, that region wears a lingering summer for years. The sun rides higher, shining through long days. Across the pole, winter settles into a deep, hushed season, lit mostly by sunlight filtered through or reflected off the rings. The sky cools, the shadows lengthen, and the palette shifts one calm tone at a time. Nothing about it is abrupt. There are no quick snaps from hot to cold. The light is far, the warmth is soft, and the changes flow like syrup instead of water. Watch the planet over decades, and you begin to feel these moods. In the 1,980 seconds, visiting spacecraft saw one hemisphere bathed in the high glow of summer. About 15 years later, cameras caught a different tilt and a different lighting. Another 15 years brought yet another look, as though the world were quietly turning a page between long acts. Saturn becomes an old friend you check on every decade, and each time the conversation picks up where it left off. Same voice, new shade. The rings make this page-turning visible in a way no other planet can match. They are grand sundials for a year that advances in slow arcs rather than small ticks. When the sun sits low for a given hemisphere, the rings may throw long slanted shadows over the clouds. When the season brightens, those same rings can brighten the sky by reflecting light instead of blocking it. The tilt changes the filter, and the filter changes the mood. Imagine a child born at the start of northern spring. By what we would call middle childhood, summer would just be beginning. Adulthood would arrive near the hush of autumn. Winter would not visit until their 30s. A person could reach retirement before experiencing a complete set of seasons. Time stretches, measured not in months, but in decades of shifting light. It lends the whole world a sense of patience, an unspoken agreement that nothing important needs to be rushed. The sun itself is smaller from that distance, and warmth arrives with gentleness. No sudden heat, no sharp cold, only long inclines and long declines, a melody without harsh notes. Dawn can last for years. Summer is an exhale held beyond the span of a plan. Winter is not a quick sleep, but a deep, restorative rest for half a world at a time. The calm is not empty, it is deliberate. Far earlier than any of these seasons, before rings cast their first shadows and moons gathered in their lanes, there was only the cradle of the system, a great, warm disk of gas and dust spinning around a young Sunday. It was not a cloud the way Earth makes clouds, but a wide, hazy sheet, the protoplanetary disk, lit by a star that had only just learned to burn. In that swirl, everything familiar began as something hardly worth noticing: dust. The story of a giant starts with what clings to a fingertip. Minute grains, drifted silicates, ices, carbon, iron smaller than sand, carried along by faint turbulence. When they touched, they tended to stick through small electric charges, and the softness of their surfaces, like flour, clumping gently in still air. Clumps became pebbles, pebbles, rocks. The growth was patient. Past a certain size, gravity joined the work, and then the gathering quickened. Bodies large enough to feel their own pull, planetesimals swept up neighbors, merged with rivals, and sometimes shattered, seeding new pieces for other hands to collect. Competition and cooperation shared the same lane. Where one body gained a little advantage in mass, gravity gave it a louder voice, drawing in more material and growing faster than its peers. This is how the seeds of planets formed their first cores. To become a gas giant, though, a seed needs to outrun a clock. The disk that feeds it doesn't last forever. Young stars thin and blow away that gas with radiation and stellar winds. In a few million years, the pantry empties. For a world like Saturn to exist, a core had to become heavy enough, quickly enough, to invite the lightest elements, hydrogen and helium, to stay. That path, called core accretion, likely wrote Saturn's beginning, a mixed core of ice and rock, gathered until its gravity could bind a deep cloak of gas. Think of a snowball rolling down a long slope, gaining more with every turn. Only here, the snow was hydrogen and helium, the lightest pair in the universe. Once the gathering took hold, the world swelled far beyond its rocky heart, becoming the kind of planet that could hold rings and guide a court of moons. Another idea sometimes slips into the telling: disk instability. In that version, a region of the protoplanetary disk cools and collapses under its own gravity quickly, forming a giant in a single dramatic fold, gas and dust together, all at once. It is a faster birth, a struck chord instead of a long phrase. Clues for Saturn favor the patient route of a core first and gas second, but the universe is generous with methods. In other planetary families, the quick fold may be the rule where ours preferred the slow build. Formation does not fix a planet's address. Worlds can migrate. They do not drift like balloons across a room, but they can be nudged by the gas of the disk, by resonances with neighbors, by exchanges of momentum with countless smaller bodies. Jupiter, Saturn, Uranus, and Neptune may have started closer together than they stand now. Their gravities tugged and yielded until the arrangement became calm enough to last. Saturn and Jupiter, especially, likely pushed on one another like partners learning a dance. A small step and a counterstep, edging outward, settling into orbits that steadied the spaces in between. It is easy to imagine Earth's story being touched by those early steps. How much water came inward? How much rock stayed to build the inner planets? How much was cleared away? In that sense, Saturn did not merely find a place to live. It helped set the stage we now walk, not with intent, but with the quiet authority of mass in motion. As the disk thinned and the pushing and pulling quieted, Saturn settled far from the sun, where light is tender and cold is ordinary. Distance became identity. Out here, hydrogen and helium were easier to keep. The planet held the breath it gathered. Closer in, those gases would have slipped away, and Saturn might have grown into something other than a giant of air. The outer system, rich in ices, offered what was needed: seeds for a core, companions that would become moons, and the raw, bright matter that later stories would shape into rings. It's tempting to tell it as tidy steps: dust to pebble, pebble to rock, rock to core, core to a world in a wide cloak. Yet the truth sounds more like music than marching. Fits and starts, lucky timings, near misses and narrow margins. A little more heat and the gas might not have lingered. A little less material and the core might never have gathered. A slightly different dance with Jupiter and the lanes of the system might have rethreaded themselves. Saturn exists because enough gentle invitations arrive together. There's comfort in that humility, a grandeur that began as motes no one would notice on a windowsill. With patience and steady pull, the small becomes the sure becomes the immense, dust to lantern, by way of time and gravity's soft hand. And when most hearts summon the picture of that lantern, what rises first is the halo, those gleaming, fine-boned bands that circle the planet like a blessing born from those same raw beginnings. From far off, they look smooth, a polished groove etched in night, silver laid on still water. The grace is disarming. You could swear the rings are one unbroken pane. Drift closer, and the surface loosens into its secret. Nothing here is solid at all. What looks like glass is a gathering of travelers' countless icy pieces, each keeping its own small promise to orbit, and together weaving the illusion of continuity. Reach your hand gently, just in imagination, toward that bright band, and you wouldn't touch a smooth edge. You'd find a hush of motion, a field of ice. Particles glide in their lanes, with a coordination that feels like kindness. Some are grains so small they would vanish between your fingers if you could hold such cold. Some are pebbles, some snowballs, some scalloped shards like the offcuts of a sculpture. A few carry the size of a car, a house, even a small boulder falling in slow time. Most of the ring, though, lives at the finer end, a sifted, sparkling texture that turns sunlight into a soft fire. This is a world largely made of water ice, simple, clean, and bright. In many stretches, the ice is so pure that it acts like a million tiny mirrors. Sunlight meets those particles and bounces back with uncommon faithfulness. That brightness, what scientists name albedo, runs high when the ice is fresh and clean, and it's one reason the rings shine so eagerly against the dark. A little dust threads the mix, a hint of organic shadow, faint colors that are almost more feeling than hue. The recipe is uneven on purposeless scales. Some regions glow with purer ice, others hold more dust or darker compounds. Those gentle differences sketch the subtle textures and shades your eye notices without effort. Watch the flow, and you'll sense the order. Every particle orbits at a speed set by its distance from Saturn. Close-in lanes run quick, the way the inner edge of a track pulls ahead. Farther out, the motion softens. The ring is not one sheet, but layers of traffic, fast and slow, braided together without fuss. From a distance, the whole thing seems smooth. Up close, it's busy with motion, never frantic, never loud, always composed. Collisions do happen, constantly, but they're not the kind that bruise. What you get is the soft tap of snow meeting snow, a nudge, a little trade of energy, then a continuation. Over long breaths of time, these innumerable small meetings do a quiet maintenance. They sand away the roughness, hold the ring to its thin plane. If a particle wanders up or down, the gentle shuffling of bumps and the tug of gravity draw it back. No overseer, just a persistent tendency toward the shared surface. In places where clumps knit too tightly, tiny impacts tease them apart. Where the material thins, gravity's hand gathers it again. The balance makes a kind of ring, weather patterns that appear, drift, and soften. Bright wakes and denser streaks that swell for a while and then ease back into the general calm. Even in a system that looks flat enough to iron, there are ripples. Little bends can rise when something disturbs the choreography. A passing moonlet, a hidden knot, a nudge from within. When the sun skims the rings at a shallow angle, those ripples throw long, delicate shadows, the kind of shadows that reveal height where the eye expected none. In certain photographs, you can read the waves as faint vertical threads, rising and settling like a breath taken and released. Stillness, it turns out, is always full of motion. Light writes moods across this world. Composition matters. So does angle. Sometimes the rings shine with the insistence of new snow. Sometimes they smolder like frost beneath a pale morning. With the sun behind them, they turn gauzy and almost transparent, and their shadows fall in sweeping curves across Saturn's clouds. With the sun shifted, the shadows vanish, and the bands glow like drawn silver, taut across darkness. There is a special brightening to backscattering, when particles fling light back toward its source. When the sun stands behind you, the rings can flare with sudden radiance, as if the universe placed a dimmer switch in your hand. Tilt the view and they quiet, and the subtler textures come forward, like satin turned edge-on. Not every reach of the rings is equally luminous. Where dust and darker compounds are more common, the mirror dims. Where collisions expose fresh ice, the surfaces gleam again, newly polished by chance. Over longer spans, a fine mist of meteoric dust drifts in from space, carrying carbon-rich molecules that settle like soot on snow, slowly tinting what was white. It is not a stain so much as a hush, a softening of brilliance that belongs to time. Here and there, larger bodies dwell within the bright swarm moonlets, stubborn clumps, seeds of solidity in a field of ice. They hardly show themselves to distant eyes, but their passage writes signatures, wakes, like those a slow boat draws across a lake, propeller-shaped patterns that bloom and fade, trails that confess a presence even when the body is hidden. The ring reads like a memory of their movements. What you're watching, really, is balance. Saturn's gravity sets the broad architecture. The subtle pushes and pulls among particles paint the local details. Collisions smooth, light reveals, and the whole arrangement holds a poise that feels impossible until you give it time. The rings are not a frozen picture. They shift, they shimmer, they evolve with a patience that human clocks rarely honor. The changes are there to see if you sit with them through months, through years. Imagine a dance floor under starlight. Every dancer keeps time not to music, but to motion itself, and somehow nobody steps on any toes. From a quiet seat on a modest chunk of ice, the experience would be both calm and surreal. Nearby pieces drift by, some lingering, some slipping ahead according to the lanes they've chosen. Sound goes missing out here. There is only movement and the sparkle of sunlight catching the smallest, faceted edges. As the ice beneath you completes its path, Saturn turns and shows you new faces. Cream, pale gold, bluish gray shift softly with your angle. It feels like watching the universe breathe, the long inhale and exhale of a world that has nothing to prove. Even the colors hide in plain sight. To the human eye, the rings lean white, maybe ivory. But look with different filters, let certain wavelengths through, and faint tints appear. A whisper of blue, a dusting of pink, a warm thread of yellow. Small grains scatter light differently than larger ones. Clean ice reflects unlike dust-coated ice. Those delicate variations are like the undertones in a pearl when it meets a beam of sun, a depth of color that makes brightness softer rather than louder. It is all so intricate for something so simple. Particles of ice and dust circling a giant planet. From that simplicity, nature has written one of the solar system's most breathtaking scenes. Order from motion, beauty from numberless small pieces, serenity from fragments sliding through space. The rings teach that perfection doesn't require stillness. It can be grown from movement, from balance, from the gentle ongoing conversation of many small parts. They shine because there are a million mirrors. They look smooth because collisions launder the roughness away. They mesmerize because their quiet behavior carries a truth. Grace can arise from chaos, elegance from shards, harmony from simple ingredients repeating the same promise. And still, they are not left to their own devices. For all their delicacy, the rings are tended not by intention, but by the precise patience of gravity. Small moons and invisible rhythms hold the edges, open the gaps, and send waves through the bands like frozen music. Scattered near and within the rings are tiny companions, some only tens of kilometers across, hardly much beside the planet they keep. Their power is not in their size, but in their timing. We call them shepherd moons because that is what they do. They guide. What would blur remains crisp under their care. What would wander stays bound. Imagine one of these moons traveling just inside a ring's edge. Its gravity tugs at the nearby particles, drawing them inward a touch. Imagine another sliding just outside, coaxing outward by the same small law. Between those two hands, the ring narrows and holds its border, an edge kept sharp by presence alone. Sometimes one moon does the job. Sometimes there is a pair, working like partners through the long, slow round. There is a slender ring, F is the name humans give it, that often looks braided, twisted, alive. Part of that strangeness is the work of Prometheus and Pandora, two small moons that flank it, one inside, one out. As they pass, their gravity reaches in and ruffles the ring, making waves and knots and filaments. Prometheus, every so often, dips into the ring's material, pulling a streamer out as if trailing fingers through water. Pandora patrols from the far side, helping keep the pull from scattering the band into space. The result reads like ongoing embroidery stitches pulled, stitches set, a pattern that never quite repeats. These shepherding touches happen in broader places too. Farther out moons lend long-distance influence, subtler but steady, helping to keep certain edges clean and certain gaps open. Without that quiet guardianship, the rings would blur into a diffused disk over time, their distinctions washed away. Beneath those shepherds lies another sculptor, even more invisible and deeply patient: resonance. This is where rhythm enters. When a moon and a population of ring particles keep orbits that match in a simple ratio, 2 laps for the particle to 1 for the moon, or 3 to 2, or any neat fraction alignments repeat, and with each repeat, the moon's gravity gives a tiny nudge, a whisper, really. Whispers accumulate. Over long stretches, they can rearrange the ring. The wide, dark lane between the A and B rings, the Cassini division, owes much of its existence to such a rhythm. There is a moon named Mimas, circling farther out. At the distance in the rings, where a particle would complete 2 orbits for every one Mimas does, the repeated tugs slowly unsettle that particle's path. Over time, it drifts away to safer ground. The resonance clears that zone like a path through tall grass, not emptiness, but a sparser place, and to our eyes it reads as a division. Resonance doesn't always carve. Sometimes it writes waves. When the nudges aren't strong enough to open a gap, they pile matter into patterns instead, density waves that move through the rings like sound through air. You don't hear them. You see them: spiral ripples where the material compresses a little here, loosens a little there. They aren't fixed. They travel and unwind, marking time in the faintest script, showing how ring particles answer a rhythm that never plays too loudly. There are waves that move up and down as well, bending waves born when gravitational influences tilt particles slightly above and below the common plane. Think of a ribbon fluttering, rising and falling in slow motion. In the right light, those vertical waves cast long, telling shadows, revealing a 3-dimensional elegance hidden in what you first took to be a flat thing. None of this requires a plan. No command center, no baton. Order emerges from motion because gravity keeps the beat. Ice circles Saturn, moons circle beyond. The tugs align and repeat. Structure appears and then persists. Given time, and Saturn's system has oceans of time, the behavior settles into a balance that can endure for years, for centuries, for longer than the human mind can comfortably dwell. It is soothing to sit with the thought that motion alone can make something lasting and calm. On Earth, we often think stillness is the sign of stability, a tidy room, a lake without a ripple. Here, serenity is made of movement. The particles never stop, the moons never stop, the resonances never stop, yet the result is elegance, sharply edged and enduring. The beauty is born from motion, not ruined by it. Picture the scene from within. A shepherd moon drifts in the distance, more presence than object, nudging particles with a pull light as breath. A density wave spirals like a frozen echo, a keepsake of some repeating alignment. There are gaps that sit open, not carved once and forgotten, but kept open by the same small tugs, repeating, repeating, repeating. The system feels alive in its own careful way, not alive like a creature, but alive like a fountain, like wind in a field of grass, like 1,000 metronomes that somehow fall into step. Some moons give their attention to a single place. Others write their signatures across multiple regions. The patterns layer, song upon song, and yet they settle into a single, peaceful melody. Each bright edge, each spaced-out lane, carries a clue about the sculptor that touched it. By listening to the rings, by reading those clues, minds on Earth have inferred where certain moons must be, how heavy they are, what paths they take. The rings serve as a diary of gravitational relationships, a record kept in ice and shadow. The longer you linger, the more the scene feels like clockwork, every moon a gear, every ring particle a small tooth turning in sympathy. Except, unlike a clock, no hand built it. It assembled itself from the simple law that mass follows mass, and from the patience of time, it keeps assembling, moment by moment, a persistence rather than a product. Resonances drift by a breath. Shepherds trim their paths by a hair. The rings answer, the music modulates, and the structure holds. The comfort in this is how it proves that order needn't be forced. Balance can rise on its own when conditions hum. Motion and harmony are not opposites. The hum of orbits, the lightest pulls, the ripple of sunlight on ice, these do not decay into disorder. They settle into shape. So when the rings bloom in your mind, let them carry more than glitter. Feel the unseen helpers, tiny moons keeping borders neat, resonances coaxing patterns from drift, waves writing slow script across the bands like whispers resting in frozen air. And then, notice another silence shaping the stage itself. Far from the inner warmth, Saturn moves through the dark with a companion you can't see, a hush of force that wraps the planet like a sleeping cloak. This companion is the magnetic field, colorless and soundless, yet able to mold space the way a soft hand shapes water, guiding charged particles, sketching auroras around the poles, and raising a gentle wall against the sun's persistent wind. It feels familiar because Earth wears a quiet shield of its own. But Saturn's version keeps an odd secret. It seems to align almost perfectly with the planet's spin, a symmetry so neat it has puzzled careful minds for decades, as if a lighthouse beam were fixed straight up the tower, unwavering, never once sweeping the dark. A planetary magnetic field acts like a guardian. Charged particles streaming from the sun try to pour in. The field turns them aside, folding space into a shelter we call a magnetosphere. At home, that shelter guides some particles toward our polar skies, where they meet air and unwrap into curtains of light. Saturn does the same, only in grand, slow strokes. The planet is larger, the spin faster, the reach of the field immense, and the solar wind worries at it constantly. Dayward, the wind squeezes the bubble. Nightward, a long tail is pulled out behind like a ribbon in the dark, twitching and bending with the sun's moods. Deep inside that serenity lies the source, the engine that never shows its face. Saturn is mostly hydrogen and helium, but pressure is a patient sculptor. Far below the clouds, hydrogen is crushed into a strange metallic state, a sea that conducts electricity like a wire wound around a core. Motion flows through that sea, broad currents, loops within loops, and by the dynamo's old rule, moving charge makes a field. You could imagine coils and copper if it helps. Only the coils are storms of metallic hydrogen, and the copper is nothing but pressure and spin. The result spills outward for millions of kilometers, threading space with invisible lines you can't touch and yet can sense by what they guide. On most worlds, the field tilts away from the spin, just enough to wobble as the planet turns. Earth's magnetic pole isn't where the geographic one lives. The difference lets us measure a pulse and mark a day. Saturn refuses that convenience. The beam seems to run along the spin so closely that no wobble appears, as if a torch were strapped to a top and pointed exactly upward. No sweep, no blink, nothing to time. This near-perfect alignment should be unstable if left to itself, the way a coin won't stay on edge unless something quietly helps. Perhaps the deep field is tilted after all, softened by some smoothing layer closer to the surface. Perhaps the rotation within Saturn is trickier than we imagined, different shells turning by slightly different clocks and confusing the signal. Whatever hides inside, the alignment is a polite riddle, and the planet carries it without hurry. The field itself is not shy about its size. The magnetosphere forms a vast cocoon that breathes with the sun. On the day side, pressure narrows it. On the night side, it stretches into a tail that can twist and then snap into a new arrangement. Particles are caught inside, spiraling along field lines. Like beads on taut threads, they travel toward the poles, meet the upper atmosphere, and bloom into light. On Saturn, those auroras glow in ultraviolet and infrared, most vividly tones beyond human eyes. But if we could see them as they happen, they would look like soft ovals and rings encircling the polar regions. They tend to be more structured than Earth's dancing curtains, steady shapes that brighten when a storm of particles arrives from the sun, or when the planet's own system feeds the field from within. That inward feeding is one of the gentler miracles. Not all of Saturn's auroras are gifts from the sun. Some draw strength from a nearby storyteller, the small ocean world of Enceladus. At its south pole, geysers breathe water vapor and ice grains into space. Those grains meet sunlight and radiation, become charged, and drift into Saturn's magnetic hush. The magnetosphere swallows this breath, folds it into its patterns, and some of that material later rains down the poles as part of the auroral glow. Light powered by a moon's exhale, Saturn gathering from both its star and its children. Watch what the field does under changing weather from the sun. A burst arrives. The day side is squeezed. The tail is stretched thin until it breaks and reconnects. The field lines snap into new shapes and let trapped particles fall planetward, pouring along magnetic paths to the polar skies. The auroras brighten and hold for hours, a slow pulse on a scale that dwarfs any storm at home. There is drama here if you count by size, but in mood it feels meditative. No roaring wind, no thunder of sound. Particles come in, are guided, are made into light, and then the system resets. A tide of energy, rising and settling, as steady as breath. Saturn's secret alignment slides into the background of this quiet cycle. If the field were tilted, its sweep would give us an easy heartbeat to time the planet's day. But because it aligns so closely with the axis, the signal goes smooth. Different methods offer slightly different answers for the length of a day, and you begin to wonder what day means for a world with no surface, clouds roaming by their own winds, an interior rotating in layers, a magnetic field perhaps lagging or leading by a whisper. Saturn seems to keep a part of its rhythm private, happy to let us listen without ever showing the entire score. Set that thought beside the other giants. Jupiter's field is stronger and tipped. Earth's wanders and rarely agrees with the spin. Uranus tumbles with a field skewed dramatically. Neptune's too. Saturn sits almost stately, field and spin in near lock. It looks like intention, but it is only physics we don't fully read. yet an elegance still withholding a chapter. That elegance stretches into the auroras themselves. Think of a quiet watch over the North Pole. The rings hover like a halo. Cloud bands spiral inward toward the pole. Within the oval, the glow brightens and dims with far-off solar weather, or with the rhythms of plasma fed from within the system. There is a softness to it, a dignity. The magnetosphere hums more than it roars, and the glow is like a giant's slow exhale, warm in tone even in the cold of truth. It's a reminder that much of what shapes worlds is invisible. Fields, flows, and forces you cannot touch are busy sculpting surfaces, guiding storms, and painting light. Saturn does not shout about it. It lets you notice if you linger. Among the family of moons that circle this planet, one carries an entire weathered mood of its own. Titan is its name, and it is not merely a rock with a thin veil. It is a world with weather, landscapes, rivers, seas, a place where clouds gather and rain falls, and channels grow and empty, where shorelines shift and dunes crawl. Everything familiar arrives with a twist, because Titan is far, and the far is cold, and cold rewrites the roles. The moon is wrapped in a dense atmosphere thicker than Earth's. Standing there would feel like wading into a deep cushion of air. The pressure at the surface is about 1.5 times what presses on you at sea level at home. Despite Titan's smaller size and gentler gravity, the atmosphere leans down with a comforting weight. Breathe, and you'd find no oxygen. But the main ingredient is nitrogen, just as ours is, and that familiarity hums like an old song heard through a wall. Then the temperature answers back, and everything becomes new. The surface chills near 179 degrees Celsius, a deep cold where water is stone. Mountains and crust are made of water ice, the way our continents are made of rock. Water takes the role of granite here, silent, hard, structural. Another liquid steps into the circle. Methane, easy, airy gas, at home, settles into a different life in this distance. It condenses into clouds, gathers into droplets, and falls as rain. It pools in lakes and gathers into seas. It evaporates again into that thick air, flows away on the winds, forms new clouds. Titan keeps a methane cycle the way Earth keeps a water cycle, a mirror made from other materials. You can imagine the sound of rain on an icy shore, slow and measured in the heavy air. Every drop carving a future creek. Walk in imagination across Titan, and the weather writes the ground. Rain laces the surface with river channels and feeds basins near the poles, where the climate runs cooler still and the liquids can linger for seasons and years. Those seas are real. Kraken Mare's a name that carries a wave all its own, and they are wide enough to sail in thought. The boat you picture would need to be armored against cold and built from methane and ethane instead of water, but the act would still be sailing, leaving a wake, measuring a horizon, listening to wind. Closer to the equator, rain grows rarer, and another sculptor takes over. Dunes run in long, patient lines, familiar shapes drawn with unfamiliar grains. The sand isn't silicate. It's made from tiny organic solids, soft, dark bits that snow out of the sky after complex chemistry in the upper atmosphere. Sunlight threads through methane and nitrogen. Reactions bloom into hazes, and those hazes fall as fine particles. Over time, the surface catches them. Winds push them into ridges that can grow hundreds of meters high and stretch for kilometers upon kilometers, quiet and assured under an amber sky. That sky is never truly clear. Haze filters the light into a honeyed dusk. The sun is a pale dot, not a bright disk, more lamp than star, and shadows are soft. Colors turn muted. Time feels slowed. The horizon looks close because the haze shortens sight, blending distant hills into warm, layered silhouettes. Clouds appear now and then, streaks, patches, systems. Methane storms can be slow, but convincing, hauling enough liquid to redraw a shoreline or feed a riverbed that then sleeps dry again. After rain, channels may run for days and then retreat to memory. Over longer cycles, the whole climate may tilt toward wetter or drier seasons that last for years upon years, leaving old deltas, stranded ridges, and layers like pages in a book only patience can read. Approach the polar regions and the map becomes water-like again. Lakes and seas set in basins shaped by time. These aren't single-ingredient pools. Mixtures of methane, ethane, and dissolved nitrogen share space, with shorelines that wander, inlets, islands, and patterns that look, wonderfully, like erosion. Radar has traced marks that resemble receding water, wave, work, a change in level that left ripples etched on the land. Waves on Titan would be gentle. Low gravity slows them, heavy air smooths them, but given time, gentleness sculpts with authority. The far shores sit under that amber light, half invisible, like a dream holding its own boundary. Between the equator's dunes and the pole's seas, plains and low hills hold networks of channels in various ages, some fresh cut, some ancient, some dry, like a story told long ago. The suggestion is climate that breathes in epochs. Wetter eras draw rivers across the land, drier ones lay dust and collect dunes, then cycles return. Slow, cold, different chemistry, yes, but rhythm, all the same. Titan's surface is not the only thing that participates. The air and ground speak to each other all the time. Methane leaves, condenses, returns. Organic grains fall in a slow, constant hush. Winds sort and lift and lay. Rivers carve and carry. Lakes fill and then retreat. Fog forms near cool liquids, a methane fog at the edges of seas, drifting like river mist at dawn, rising and sinking with temperature and humidity. Picture standing on a stony beach of water ice pebbles, the fog slipping past your knees. The far shore faded to a suggestion. The air would be thick and quiet. Sound would travel differently, softened by the density. Your steps would be light from the low gravity, yet each motion would meet a gentle, velvet resistance, as if the world itself were a warm blanket held against your chest. All of it invites comparisons to home, and all of it refuses to be too simple. A lake here isn't for swimming. The liquid would burn your skin with cold. A raindrop wouldn't refresh. It would frostbite exposed flesh on contact. You could not breathe the air. Titan is an echo of Earth through deep distance and deeper cold, a familiar melody played on different instruments. The roles are reversed. Water is the stone, methane and ethane are the rivers. Beneath the hard crust of water ice, there may be another wonder, a hidden ocean of liquid water, mixed with antifreezes like ammonia or salts, warmed by the moon's slow internal heat and the tides of Saturn's pull. If it exists, it stays out of sight, a quiet sea under a roof of stone-hard ice. The surface, though, keeps the conversation with the sky. Methane fog settles and thins. Hazes drift down and feed dunes. The winds comb lines into the sand. Channels age and braid. The seas wait, mirror still, or ruffled by a wind you cannot quite hear. A traveler here would have an easy time with walking and a hard time with feeling. Gravity would be kind. The pressure would feel oddly normal to the body, a firm embrace rather than a squeeze. But the cold would be complete, the air unbreathable, the horizon close and private. It would be a place for reflection, not for rush. A place where time seems to stretch, and the ordinary act of watching a cloud would be enough for an afternoon. It is easy to love Titan for its patience and for its courage in using a different recipe to make familiar beauty. Wind, rain, erosion, seas. Nature didn't need water and rock and oxygen to write those words here. It wrote them with nitrogen, methane, ethane, and light filtered through haze. The dunes wear the same grammar as deserts at home. The lakes draw the same letters as ours. The rivers branch and wander with the same logic that gravity teaches anywhere. Beauty doesn't belong to a single chemistry. It is a pattern that repeats whenever the universe finds balance. Saturn holds this world in its family, and the magnetic field that glows at the poles listens to contributions from the moons, drawing in grains from Enceladus, holding the orbit steady. Letting Titan keep its weathered dreams without interference, the planet moves on, ringed and calm, field aligned almost as if on purpose, auroras breathing in slow ovals, a mystery wrapped in order. And Titan, drifting in that distant light, keeps its seas and dunes and fog, a small earth rewritten by cold. Together they show how quiet strength can look, a shield that hums instead of shouts, a sky that glows without flame, a landscape that sculpts itself in patience, invisible hands, visible grace. A dialogue carried by magnetism and rain, whispered across the dark, and so gentle you can hear it even now in this dim room, with your breath slow and the night leaning close. When we wonder where life might be hiding beyond home, the mind often reaches for warm water and blue skies. Titan asks a softer question. Could something living begin in a place that is not warm, not watery, not like Earth at all? Imagine a laboratory written in dusk and deep cold, where chemistry takes slow paths and patience is the first ingredient. The idea isn't to force Earth's recipe onto another world, but to loosen our grip and open our hands. Titan does not promise us oceans like ours at the surface. It lays out methane and ethane instead, liquids that behave as water does here, evaporating, gathering into clouds, falling back as rain, pooling in lakes and seas that stretch under a dim golden light. If life could learn to move within that kind of lake, it would be life drawn in a different script. Water at home is a polar liquid. Its slight charges invite salts and molecules to dissolve, to meet, to react. In Titan's cold, methane is nonpolar and shy with solutes. Reactions are slow and careful, and the cold makes every motion measured. Yet slow does not mean impossible. If organisms swam in methane, they would need membranes unlike ours, not soft sacs of fats, but shells shaped for a hydrocarbon sea. Minds on Earth have imagined such envelopes and given them a name that feels like snow: azotosomes. Built from nitrogen-rich molecules, these theoretical membranes could remain flexible in liquid methane at Titan's temperatures, making small rooms for chemistry to take shelter inside. No one has seen such a cell wall. It is a thought experiment, cradled by equations, but it shows how gently the rules could shift. Not warm water and fats, but cold methane and nitrogen structures, still protecting a whisper of inner life. Even while the surface plays its slow story, Titan may hold another possibility below. Beneath the hard shell of water ice, there could be a global ocean of water mixed with ammonia, a blend that stays liquid far below zero, because ammonia lowers water's freezing point, like a lullaby lowers a child's heart rate. In such a sea, chemistry could move with more ease than in methane lakes. Minerals might dissolve from a rocky floor, heat could seep in from within, and molecules could try on more complicated shapes. It draws a double portrait, a cold surface where methane lakes test patience, and a hidden ocean where water and ammonia practice a different rhythm. Two potential homes for life, layered like pages, each with its own alphabet. But a liquid isn't enough. Life also needs a power source. Sunlight at Titan arrives as a weakened pulse, and the thick haze dims it further. The light that reaches the ground is enough to shuffle the methane cycle, but likely not enough to feed a bright, green world. If anything living works at the surface, it might sip energy from chemical gradients instead, breathing the atmosphere's gifts, eating the difference between two kinds of molecules, the way some microbes at home eat minerals rather than light. Titan is generous with ingredients. High above, sunlight and charged particles stir methane and nitrogen into a chemistry set that will not stop. Heavier organics, long chains and branching rings form and drift down like slow, invisible snow, settling into dunes and soils. A pantry restocks itself from the sky, day after dim day. Deeper in the possible ocean, energy could rise from the ground. Saturn's pull needs Titan a little with every orbit. That tidal kneading can make heat, not enough to melt the surface, but enough to keep water liquid below. If rock lines the ocean floor, water and minerals could meet in reactions that release energy, an echo of hydrothermal vents on Earth, where entire ecosystems live on chemistry alone. No sunlight, no photosynthesis, only the quiet generosity of stone and water making food from gradients. We do not know whether Titan's ocean hosts such vents, but the thought sits soundly within the physics we carry. All of this makes Titan a place worth visiting, with careful tools and gentle questions. A craft is being prepared with that softness in mind. Its name feels light on the tongue, Dragonfly. Not a rover that crawls, not a lander that sits, but a rotorcraft that flies. Titan's thick air and low gravity make flying easier than at home. The same haze that dims sunlight can lift a careful machine. Dragonfly will rise into amber skies, hop from dune to dune, glide above ancient channels, alight on deposits rich in organics, and pause to taste and listen. Where a rover might trundle one path, Dragonfly will explore many. Its work is not to find creatures outright, but to test possibilities, to read the chemistry of sands and ices, to assess whether building blocks can assemble under such cold, to ask if impact craters briefly melted ice into pools, where water-based reactions might have tried a first step before freezing again. Picture the craft hovering in twilight, lights gentle, rotors whispering, moving from a dark dune sea to the rim of a crater where heat once bloomed. It lowers, lands, opens its instruments like a field notebook, and begins to measure. Are the long-chain organics capable of growing into more elaborate structures? How do solids on the ground speak to the methane seas and the frozen crust? Are there hints that the deep ocean ever reaches up cracks, seeps, or thin places where material from below can carry nutrients to the surface? Each answer will be quiet, but together they will teach us what chemistry looks like at the edge of habitability. Expectation must be gentle, too. If any life inhabits Titan, it may be microscopic and slow, its clocks stretched by cold. Reactions that take seconds here might take days or longer there. A heartbeat could be a season. A division of cells could be an era. Even if Titan is lifeless, the world still gives a lesson worth keeping. Complex organic chemistry thrives in places that do not resemble Earth, and habitability is not a single point, but a wide field shaped by temperature, chemistry, time, and chance. The moon tells us to loosen our criteria, to ask what is essential for life and what is only familiar. Hold the scene of Titan's twin invitations: an amber surface where methane rains fill lakes, and a secret ocean beneath, dark and possibly warmed by tides. Between them lies a world fluent in patience. If life can wear garments shaped for methane at the top or water ammonia below, it means the universe is kinder to possibilities than we have been. Blue oceans are one way, amber seas could be another. Photosynthesis is one path, chemistry that feeds on gradients is another. Water-filled cells are one design, azotosome shells, perhaps, are another. The lesson is soft, but deep. Life, if it exists elsewhere, may not look like us, and still, it may flourish, quietly, under alien skies. Farther out in the same family, a smaller world shines with a different promise. Enceladus, bright as fresh snow, only a few hundred kilometers across, should be too small, too cold, too quiet to matter. Instead, it has become one of the most persuasive places to look for life. Beneath its mirror-white crust lies a global ocean of liquid water. And where most ocean worlds hide their seas behind miles of ice, Enceladus sends part of its ocean into space, in plumes, jets of vapor, and tiny grains like a whisper it can't resist sharing. From a distance, the moon looks carved from clean ice, ridges, plains, crisscrossing cracks that read like frost on a window pane. Near the South Pole, 4 long fractures run in parallel, deep, dark, and warm by comparison, nicknamed tiger stripes. Along those stripes the plumes lift, sometimes billowing, sometimes subdued, but always returning. Spacecraft have flown through them and tasted their contents, sampling the ocean without a drill, without a descent through kilometers of ice, water, salts, organics. Silica grains so small they move like smoke. Each ingredient is a clue, and together they form a picture that feels more solid the longer you look. Before the evidence gathered pace, some imagined only local seas, below pockets under stress, regional reservoirs. But flybys that measured tiny wobbles in the moon's spin showed a different interior. The way Enceladus shifts as it orbits Saturn makes sense if a global ocean decouples the shell from the core. The ice becomes a lid, not a body. The sea becomes the body, not a pool. The depth of that ocean may run tens of kilometers beneath a shell whose thickness changes with place thinner near the tiger stripes, thicker elsewhere like a breathing roof. What raises the hope higher is the hint of heat where water meets rock. Those silica nanograins in the plumes likely form when water interacts with hot rock at temperatures around or above 90 degrees Celsius, then cools and carries its tiny glass outward. On Earth, such conditions mark hydrothermal vents at the seafloor, chimneys and seeps where water, heated by the planet's interior, leaches minerals from rock and rises, rich with energy. Entire ecosystems thrive there in darkness, fed by chemistry alone. If similar vents line Enceladus's seafloor, they could make refuges where life could take root and persist microbial, quiet but real. The heat to drive such vents doesn't come from sunshine. It comes from gravity's hand. Enceladus keeps a resonance with a neighbor. For every 2 laps Dione makes around Saturn, Enceladus makes 1. That rhythm stretches and relaxes Enceladus as it moves, warming the interior through friction the way kneading warms dough. Over long spans, this tidal heating prevents the ocean from sealing itself into permanent ice and may power the chemistry that writes minerals and feeds microbes. Salt in the plumes tells us the ocean touches rock long enough to dissolve it. Organics in the plumes tell us carbon chemistry is present. Water, energy, minerals, organics, 4 signposts that always pull our attention. Let the mind drift below the ice. The ocean would be dark, the pressure heavy and constant, the water brimming with salts and trace compounds. Somewhere, vents could be releasing warm, mineral-rich water into the sea. Around them, chemistry might climb little ladders, simple molecules forming, breaking, recombining, some stable enough to persist, some accidentally building scaffolds that could, in time, hold a pattern. We do not need to add fantasia to feel the pull. The place has what we look for when we look for habitability, and it has a natural pipeline to share that place with space. Sampling those plumes is the kind of grace planetary science rarely gets. A craft can fly through the spray and collect a snow of truth, then read its chemistry in detail. Are amino acids present? Are there chains whose lengths and shapes hint at biological preference rather than random assembly? Are there isotopic patterns that lean the way life tends to lean? Is there anything cell-like shells, vesicles that survive the ride into the sky? Some imagine a mission that passes repeatedly, collecting gently to avoid breaking fragile signatures, building a library, grain by grain. Others picture landing on the South Polar terrain, watching the geysers, catching their frost at the source. A figure of a machine, standing in the glitter of a moon's breath, listening to the ocean's whisper through a veil of ice. Even without touching down, such flybys have already erased doubts that once stood tall. The plumes aren't illusion. The ocean isn't local. The chemistry isn't poor. What remains is the heart of the matter. Is there life? If the answer is yes, even a single microbe, the story of life broadens at once. That would mean life can begin in a sunless ocean, warmed by tides and fed by rock, and the number of places in the universe that count as possible would swell. If the answer is no, the lesson is still sweet. Worlds unlike Earth can assemble everything but life. And that too tells us which ingredients are essential and which are simply helpful. Enceladus carries its quiet with a kind of pride. Its surface is not violent. Its weather is a skin of ice. Its drama is microscopic grains that arrange themselves into truths. The plumes curl outward, snow falls back and powders the ground, and the moon remains the brightest thing in Saturn's system, a mirror that hides an ocean and reveals it at once. Standing there in imagination, frost gathering at your boots, the sky black and full of stars, you could look up and see the faint smear of a plume and know that each grain holds a message from the sea. Together, Titan and Enceladus stretch our sense of what habitable might mean. One teaches patience in cold liquids under an amber sky, where membranes might be made of nitrogen shapes and rain is methane. The other offers warmth where warmth should not be, a sea in the dark, with energy rising from stone, and a gift of samples we can read without drilling. They ask us to stop demanding a mirror of Earth and to start recognizing families of possibility. Blue oceans, amber seas, photosynthesis, chemisynthesis, fats and water, azotosomes and methane, gravity tugging a moon into warmth, sunlight filtered into dusk and cloud. The details change, the principle remains. Life, if it can, will learn the local language. If there is anything tender to carry from these distant places into the quiet of your room tonight, it is that life may be both rarer than we hope and more flexible than we imagine. Titan may hold only promise and no pulse. Enceladus may hold all the ingredients and only silence, or both may be practicing forms of living that our eyes are not yet trained to see. Either way, they widen the field and steady the spirit. In a cosmos that can make rings thin as whispers and oceans in the dark, it is not hard to picture a cell learning to keep itself together under strange skies. It is not hard to picture a chemistry that feeds itself without light. It is not hard if you breathe slowly and let the mind unclench to feel that we are surrounded by chances, not loud chances, gentle ones. The kind that drift down like snow from a plume or collect as organics on a dune, waiting for time. Among Saturn's many small companions, some drift with a quiet dignity, some keep a private riddle, and some wear their strangeness like a smile you can see from orbit. Each of these worlds moves within the planet's wide embrace, shaped by ice, rock, time, and the subtle etiquette of gravity. They may not all carry seas or thick skies, yet their personalities are unmistakable quirks and contours that make you pause in the dark and wonder how nature can be both precise and playful at once. There is one that looks as if a careful hand painted two truths across a single face. Iapetus turns with a mask of contrast, one hemisphere so dark it swallows nearly all the light that touches it, the other bright as piled snow. From space, the division reads like a great yin and yang, night folded into day, day into night. As if that weren't enough, a narrow mountain range climbs along its equator, a ridge that rises more than 10 kilometers high and runs for hundreds of kilometers, a seam stitched almost perfectly around the middle. Seen from afar, the moon takes on the shape of a walnut or a pressed truffle, one side dusted with chocolate shadow, the other left bare and pale. The stories told for its ridge are gentle hypotheses. Perhaps Iapetus once spun fast and then slowed, the equator bulging and freezing in place. Perhaps a ring of debris drifted down and settled into a belt. Piling mountains where particles landed, the dark and white coat may be part native ice and part foreign dust, material falling inward from elsewhere in Saturn's realm. However it came to be, the moon wears its asymmetry with a calm pride, a world split in color and in character, yet whole. Another body keeps an altogether different texture, more like an art piece left to breathe in cold air, Hyperion. Imagine a sponge of ice, riddled with deep, sharp-edged hollows, its surface pitted into geometry that looks carved and never softened. If you tried to walk there only in thought, your steps would find hollows and airy crust, a frozen foam with voids beneath. Hyperion's low density suggests it is loosely packed rather than solid through and through, a porous bundle of ice and rock that holds more emptiness than most worlds do. But it is the motion that startles in the gentlest way. Hyperion doesn't keep a steady spin like a contented top. It tumbles. No single day length, no fixed orientation. It wobbles under the quiet persuasion of Saturn's pull and the nudges of neighboring moons. Watching it turn is like watching a tossed pebble somersault slowly, except the pebble is more than 200 kilometers across and has been tumbling for ages. You feel no chaos in your chest when you look, only the sense that here is an object that refused tidy rhythm and was allowed to keep its own. Mimas draws a different kind of attention, a small world marked by a single enormous bruise. The crater named Herschel takes up so much of one side that the likeness to a certain movie station is impossible to ignore. The comparison is playful, but the wound is real, a reminder of how force can remake a body in an instant. If the impact had carried much more energy, Mimas might have shattered. Instead, it survived with a scar that makes it instantly recognizable. Modest in size, quiet in most other ways, it still lends its gravity to the system's choreography. Through resonances, its tug helps trace patterns and open gaps among the rings, its influence extending well beyond its small circle. In the rings themselves live moons so tiny, they feel like characters in a bedtime story. Pan keeps house inside a narrow gap, sweeping debris aside as it goes, and leaving behind a neat path called the Anka Gap. Its shape is a charm in miniature, a central body with a delicate equatorial skirt, as if ring particles had settled softly around its waist and stayed. Some people think of a dumpling, some say ravioli. Atlas wears a similar outfit. Over time, as these small worlds clear their orbits, they gather a little of the ring material and keep it, their own icy collars grown from the very band they shepherd. These shapes are gentle examples of how motion and gravity can dress a small thing in unexpected clothes. Prometheus plays nearer to the narrow F-ring with a mischief that never breaks the rules. Each pass tugs softly at the ring's edge, drawing out streamers and braids, leaving wakes that shift with every orbit. The ring responds like hair and water knots, forming and loosening, delicate patterns that show off the moon's touch more than the moon itself. If you imagine the moons seated together, Prometheus would be the friend who can't resist rearranging the centerpieces, always with taste, always with a glint. Two others, Janus and Epimetheus, prefer a partner act. They share nearly the same orbit, and rather than collide, they perform a slow exchange every few years. As the inner one catches the outer, they trade places. The inner drifts outward, the outer drifts inward, and both carry on. Picture two skaters gliding close, clasping hands for a breath, and then releasing, each taking the other's path. They've kept this pattern for centuries, a durable kindness written in gravity and time. Even the moons that seem more subdued carry marks worth tracing with a fingertip. Tethys shows a canyon so long it nearly wraps the globe, an immense scar known as Ithaca Chasma, like a memory written across almost an entire latitude. Dione's face is threaded with bright cliffs and fractures, icy scarps that glisten like white threads under sunlight. And farther down the list of names, small irregular bodies crowd the system's outer edges, captured fragments and lumpy companions, some gathering a fine frost of particles on their surfaces, some keeping shapes that betray a history of gentle collisions and slow spins. If each had a voice, the gallery would hum with different timbres, a low, round tone from the larger spheres, airy notes from the lopsided stones, a choir that only the distance can keep in tune. What makes this neighborhood so endearing isn't only variety, it's individuality. Hyperion's sponge, Iapetus's dark and bright mask, Pan's dumpling waist, Mimas's single eye of an impact, Janus and Epimetheus swapping paths like patient dancers. Each one seems shaped by a local rule, a particular past. To wander here in thought is to move through a sculpture hall where everything was carved by gravity and time rather than by hand. Some pieces catch your breath, some lift the corners of your mouth. All ask, quietly, for curiosity. Long before our first close look, before the rings were seen from within and the auroras were measured in radio hush, a small traveler, left home to keep Saturn company. The Cassini spacecraft was built for patience, not haste. It carried a companion, too, a lander called Huygens, designed to visit Titan. Two agencies on Earth, two continents apart, worked as one to send them out together. The launch came in the late 1990 seconds. The journey was clever rather than fast. Gravity assists from Venus, then Earth, then Jupiter, each world lending a little speed like a friend giving a push on a swing. Nearly 7 years later, Saturn rose to meet the craft, not as an end, but as a beginning. Capture into orbit felt like a held breath released. Cassini eased into the system, turned its instruments on, and began to circle. Again and again, hundreds of times. It did not barge in. It threaded careful paths, sometimes high above the poles, to watch cloud tops swirl, sometimes sliding low through the ring plane, to learn how delicate and thin those bands truly are. It watched the moons as if meeting neighbors on a slow walk. Dione, bright; Tethys, scarred; Iapetus, half in shadow; Hyperion, full of holes; Mimas, wearing its crater plainly. It took its time, because Saturn moves on long clocks, and patience is how you hear a slow song. When it was time, Cassini released Huygens, and the lander fell gently through Titan's golden sky beneath a suite of parachutes. That descent in early 2005 became the first landing in the outer solar system. The little craft sent images and whispers as it dropped. The hazy air parted into a landscape with channels and shorelines, a surface shaped by liquids that are not water, a geometry no human had touched. Cassini listened from above, relaying the last murmurs until the cold took them, then turned back to its long orbit and kept watch. From there, the tour became a book you wanted to read slowly. The cameras saw Saturn's atmosphere in pastel layers, steady bands, storms that widened and narrowed, a cyclone at the pole with an eye like a hexagonal secret. Seasons changed imperceptibly, and then not. Shadows slid across the rings, the light shifted, and new edges appeared. The rings themselves unfolded into complexity. Waves seemed to travel through them. Spokes developed and faded like brushstrokes. Tiny moons sculpted gaps and feathered rims. The system moved like a music box wound once a season, then left to play across a long year. Cassini's senses extended beyond sight. Instruments listened for the planet's magnetic whisper, tracked radio and plasma waves, and smelt the faint chemistry of gases and dust. It felt, in gravity's slight tugs, the mass of things it flew by. It even tasted catching tiny grains that drifted into detectors and reading their composition. Through these senses, the spacecraft found that Saturn's magnetic field aligned so closely with its spin that timing the planet's rotation became a puzzle. The familiar method, listening for the lighthouse blink of a tilted field, failed because the beam shone straight. It was a quiet riddle, as gentle as Saturn's auroras and as persistent. Surprises kept arriving with the same soft footfall. Geyser-like plumes at Enceladus's South Pole, jets of water vapor and ice grains and organics, proved that a small moon could host a global sea beneath ice and send samples into space. Titan's lakes changed with seasons, clouds came and went, and shorelines hinted at cycles older than our calendars. A long-lived storm blossomed and then mellowed. Ring features evolved under the rubbing of resonances and shepherding moons. The portrait deepened, not a static postcard, but a living, slow-motion world. Years slipped by, and the mission found itself extended, not rushed extensions, but thoughtful ones, adding time so Cassini could see the system in changing light. The spacecraft became a witness to Saturn's long seasons, a chronicler that trusted patience. And people on Earth learned to expect the tenderness of its images, the rings backlit like lace, the crescent of a moon caught against the planet's shoulder, and once, famously, Earth itself, tiny, blue, below the ring's shadow. On that day, people stepped outside, waved at the sky, and later found themselves in a photograph taken from more than 1 billion kilometers away. The picture carried data. It also carried solace. Cassini never hurried. Even as its fuel dwindled, it threaded new paths, adjusted its orbit, slipped between the innermost ring and the cloud tops in a series of daring dives that felt somehow serene. If a machine can have a temperament, this one had the patience of a careful friend, delivering what it learned without fanfare. By the time its last chapter was being planned, the team had shaped an ending that honored the places it had touched. To protect worlds that might harbor fragile chemistry, Titan, Enceladus, the spacecraft, would not be left to drift and someday fall the wrong way. Instead, it would return to Saturn itself and become a part of the place it had studied. Before that descent, the ledger was already heavy with gifts: a moon with 2 faces and a mountain seam, a sponge that tumbles, a dumpling that tends a gap, a small world with a crater like an eye, 2 companions that trade orbits with grace, canyons, cliffs, folds of ice, a ring system alive with waves and whispers, a planet whose magnetic poise holds a mystery, a hazy moon with lakes of methane, a bright moon with a warm ocean beneath. Cassini had shown us the quiet power of watching for a long time. It had proven that wonder doesn't always arrive with noise, that sometimes it is a fine pattern in a ring, a faint plume against black, a pale dot beneath a lantern. If you let your mind drift now among the small moons again, the system feels like a neighborhood. There are the orderly dancers, keeping step without colliding, the eccentrics happily offbeat, the quiet giants, holding their own weather and scars, the playful guests who pull streamers from the table's edge and make the arrangements lovelier than before. Gravity is the host who never loses patience, and time is the music, slow and unending. Nothing here tries to impress, and still, the impression stays with you. Variety, arranged into harmony. Individuality that never interrupts the whole. It becomes easy, in the dim room of thought, to imagine a walk among sculptures that no sculptor made. At Iapetus, you run a fingertip along the ridge and feel the seam. At Hyperion, you look into a crater and see the texture of frozen foam. At Mimas, you step back to take in the scale of the wound and the survival. At Pan, you smile at the little skirt and the well-tended gap. At the F-ring, you watch Prometheus tug out a streamer and let it fall back into place. At Janus and Epimetheus, you wait for the moment when paths touch and then part. At Tethys, you circle a chasma that threads almost the whole world. At Dione, you stand at the foot of icy cliffs that gleam like bone in winter light. And somewhere in the distance, a small craft moves steadily on, recording, relaying, teaching, then bowing out with a grace equal to its patience. Saturn's family shows that the universe can be serious and light-hearted at once, that it can set a ridge exactly along an equator, spin a sponge into a tumble, dress a pebble in a ruffled waist, and choreograph 2 bodies to change places without ever colliding. It shows that imagination isn't a human invention. It's a property of physics, revealed when gravity and ice and time are left alone to play. And because we were willing to fly outward and linger, willing to watch more than to demand we were allowed to see it, if you close your eyes now, you might still picture the rings, thin as a whisper, the moons, each with a different voice, the planet wearing its calm like a lantern shade. And far behind your eyelids, a small blue dot framed in a halo, waving. Exploration can be as simple as staying long enough for a world to speak. Cassini's long companionship with Saturn held to that gentle rule. In its final months, the spacecraft leaned closer, not with drama, but with care, threading the slim corridor between the innermost ring edge and the top of the planet's clouds. No one knew what waited in that narrow hush. Some imagined a storm of ice, grains, and dust, the shed fringe of the rings. Cassini lifted its antenna like a small shield and slipped through. What it found first was quiet. The gap proved cleaner than expected, a faint drift of particles rather than a torrent. That single surprise softened old assumptions about how the rings feed the planet. Instead of a steady downpour, the inward fall looked more like a slow, delicate weather, less highway, more buffer, the movement between ring and world lighter than we had guessed. Those dives turned Saturn itself into a subtle instrument. As Cassini swung low, tiny variations in gravity tugged at its path, and the tug wrote a map of hidden mass beneath the clouds. Saturn has no solid floor, only layers of gas and fluid braided into flows. The graceful bands we see, beige, gold, cream, race around the planet, and the question had lingered, are those winds only a skin, or do they reach downward? The gravity told the truth with a whisper. The winds extend deep, sinking thousands of kilometers below what the eye can see. Weather is not a surface trick here. It is the breathing of the planet's interior, a vast ocean of motion whose surface happens to be clouds. The stripes we admire are only the upper lip of a long river. Close passes also let Cassini listen to the magnetic hush from a dozen angles. Saturn's field has always sat a little apart from expectations. On most worlds, the magnetic axis tilts from the spin, casting a lighthouse sweep by which we can time a day. Saturn's beam points almost straight, and the sweep goes missing. The grand finale orbits sharpened that puzzle. The alignment is even tighter than we thought. Deep inside, where hydrogen is squeezed into a metallic state and flows like a conducting sea, the motions that drive a dynamo somehow keep their symmetry. The result is a field so neatly aligned with rotation that it hides the very heartbeat we usually count. Models adjusted their boundaries. The region of metallic hydrogen became a little clearer in shape and reach, but the central question, how such exquisite alignment persists, remains an invitation left on the table. Another long-standing curiosity turned from guess to measure. The rings tug, too lightly but enough. By comparing Saturn's pull with the small additional pull from the rings, Cassini helped weigh them. The answer leaned toward lightness, not gossamer thin to the point of pretense, but lighter than some had imagined, a result that nudged the story of their age toward youth, perhaps not as young as stories told at the scale of human lives, yet possibly only a few 100 million years on the clock of worlds. Young enough that, for much of Saturn's history, the planet may have traveled undecorated. Young enough that brightness makes sense, clean ice reflects like a promise kept. Old rings would have swallowed more cosmic dust and grown darker. The dives also tasted a quiet rain. Water, organics, tiny grains, a chemistry falling inward from the rings into the top of Saturn's atmosphere. The drizzle is slow, but persistence is the law here. Over long spans, the exchange alters the air and thins the rings, a soft erosion measured in silences rather than breaks. In those same passes, instruments sampled the gases above the clouds directly for the first time. The air was not simple. It was layered and laced with material from above, molecules born in rings surviving the transit into sky. Rings and atmosphere, once treated as separate pages, read more like facing lines of a single poem. Even the planet's day, the length of a deep rotation, came into focus. Gas giants do not give up their spin easily. Clouds move at different speeds. The magnetic clock is uncertain when the field refuses to tilt. But by holding gravity and magnetism together, the team narrowed the rhythm more precisely than before. A true day is not a number you carry around. It is a way of saying we can hear the core more clearly. Each dive felt composed. Between ring and cloud top, Cassini flew, gathered, and turned, letting that once unknown interval become a place of knowledge. And when the time for parting came, the last decision kept to the mission's tone: care over spectacle. To protect the fragile chemistry of Titan and Enceladus from any chance of earthly microbes hitching a ride into their futures, the spacecraft was guided gently into Saturn's atmosphere. Even then, it worked, sending back the feel of the air composition, density, temperature, turning its descent into one last gift. The signal faded not with a shout, but like breath released, and the craft became, at last, part of the sky it had studied. The closing chapter did what the best endings do. It clarified. It showed the clean hush between ring and world, traced the depth of winds, refined the magnetic riddle, weighed the rings, caught the rain, tied the atmosphere to the ice, and tuned the measure of the planet's day. The lesson was the same as in the beginning: lean in, listen longer, let the world reveal itself in its own pacing. Rings are easy to imagine as forever. They sit there like wedding bands in the sky, dignified, serene. But look closely, and time is everywhere. The question of their age holds two gentle truths and a handful of maybes. Brightness suggests youth. Fresh ice throws sunlight back so eagerly. If the rings had stood for billions of years unchanged, tiny meteoroids drifting through Saturn's orbit would have smeared them with dust, softening their sheen more than we see now. Lightness points the same way. Less mass means less time to darken, less time to erode. And yet, structure and dance with the moon's whisper of longer histories, a possible origin in the messy youth of the solar system, the aftermath of a shattered moon, or leftovers that never gathered into a larger body. Perhaps both stories are part of the truth. Perhaps the rings formed long ago but were freshened later by a new supply of ice, snowfall on an old field. Saturn keeps its birthday mystery with a courteous smile. About the future, the signs are clearer. Material is leaving. The phrase ring rain is tender and exact. Tiny particles drifting inward, nudged by Saturn's magnetic field and the thin atmosphere at ring edge. Falling through the gap Cassini crossed and dissolving into the planet's upper air. The spacecraft felt that drizzle, counted its grains, and read a rate, not a deluge, only a patient weather. Over eons, a patient weather remakes any landscape. The atmosphere absorbs what falls and changes by the smallest degrees. The rings lose what falls and thin with time. Darkening is part of the slow change too. Micrometeoroids pass through like itinerant painters with soot on their sleeves, leaving faint marks. Each collision dusts the ice. Every millennium the balance shifts, slightly less pristine ice, more foreign speck, brightness softened like linen after many washings. Seen from far away, the bands hold their grandeur. Up close, the system is a living fabric of collisions and separations, clumping and spreading, all of it guided by Saturn's pull and the small touches of moonlets that carve, pinch, and comb. Imagine the paths ahead as a set of quiet stories rather than a single fate. In one, the drizzle wins and the rings fade. century by century, until Saturn keeps only a memory of a halo. Not soon. The estimates speak in millions upon millions of years. No night sky we know will notice the difference. In another, recycling keeps the bands present, but changed moons, feeding ring ice with every strike, tidal events, returning fragments, occasional catastrophes, refreshing arcs with a snowfall from a broken body drawn too close. There is even a thinner, more ghostly outcome to picture, where the rings never leave but become whisper light, more like the faint bands of Jupiter or Uranus, visible mostly to instruments and eyes with help. None of these stories steals meaning. In each, the rings remain themselves, a balance between making and unmaking, a dance between gravity, sunlight, dust, and time. Impermanence lends tenderness, not loss. To know the rings are in motion toward a different look is to love them as we love dusk. The beauty is sharpened by the knowledge it will pass. The time scales are a comfort, too. They will not slip from us. They will change beyond our counting. If their edges soften, it will be to a rhythm slower than our species can hear. Earth will write new chapters of its own before Saturn's crown looks much altered. For now, the arcs still blaze, shadows still sweep across the cloud tops, telescopes still find lace where an eye expects glass. The bands shed, gather, darken, brighten, and hold their poise. All along, the rings have taught the same simple thing that Cassini practiced. Beauty in the universe is often the mark of a system balancing many small motions, many small exchanges. The origin can be debated, the future can be drawn in several ways, but the present is unmistakable. Ice, gravity, light, time, they have made a moment that we are lucky to share. Looking at Saturn now is not like looking at a monument. It is like looking at a living tide. The most fitting response is to marvel with patience, to let the sight settle, to breathe with it, to recognize that somewhere, high above a pale blue dot, a world is still polishing its own myth with 1,000 small hands. Hold this with a soft certainty, like anything shaped by time. Saturn and its rings are a luminous chapter in an ever-changing book. When you picture the planet and its companions, it's easy to imagine a perfect mobile hung in black velvet, each moon fixed, circling forever, a sculpture that never moves. But the truth is gentler and more alive. This realm isn't a still life, it's a slow dance. The axis leans, the moons trade whispers of energy, orbits stretch and loosen like well-worn ribbon. Everything drifts carefully, gracefully keeping time with gravity's patient metronome. One of the quietest surprises is that the moons are, bit by bit, slipping outward. We feel it at home with our own moon. The same tide work happens here. Not the beach tide, but the deep tug and flex that bodies exert on one another. Saturn's pull raises bulges within itself. The moons raise them too. Because Saturn spins once in roughly 10.5 hours, while many moons take days to loop around, those bulges don't line up perfectly. The slight lag acts like a thumb on the scale, transferring a breath of spin energy from Saturn to the moon's paths. And so, almost imperceptibly, they spiral outward. The pace is slow beyond slow, slower than mountains grow, slower than continents drift, but time is generous. Over millions of years, the change becomes a new map. Outward drift doesn't just draw arcs wider, it also kneads worlds from within. Uneven pulls flex a moon's interior, icy shells and rocky cores bending by a hair, and the flexing makes warmth. Tidal heating turns cold mathematics into comfort. especially for bodies like Enceladus, with oceans beneath ice. The surface may be night cold, but within, water stays liquid, currents stir, minerals and nutrients circulate. Here, heat is not a gift from sunlight. It's a rhythm shared by orbits. Energy flows where you wouldn't think to look, sustaining chemistry that might have slept without it. What seems like a small adjustment in distance becomes, over ages, the difference between frozen silence and a living sea. Saturn's own lean joins the story. The planet is tipped by about 26-27 degrees, and that tilt writes seasons into its long year. Why the lean? One soft idea, a resonance that once linked Saturn's spin with the slow drift of Neptune's orbit, a long duet that nudged the axis little by little until the tilt settled where we see it now. Another thought threads the moons into that history, their outward march subtly changing how mass is distributed, coaxing the planet's orientation with the lightest of hands. If the tilt did change, so did the way light paints the clouds and the way the rings lay their shadows across the atmosphere. Even the most magnificent features are not fixed in their roles. The choreography evolves. Resonances braid through the family like repeating motifs in music. Some moons fall into neat ratios, 2 orbits here for 3 there, or similar simple clocks. When those patterns hold, effects amplify. Tides grow stronger, migration rates shift, surfaces crack and heal, ringlets ripple. Over millions of years, partners meet and part, drift into step and drift away again. A small nudge, a changed beat, and the pattern rearranges itself into a new harmony. There is no final pose, no celestial freeze frame. The system remains whole precisely because it keeps adjusting. If you picture a ballroom, Saturn turns at the center, rings sweeping like a bright gown that never snags, and the moons glide at many distances. Some keep smooth, predictable steps. Others share brief, repeating embraces that change both their pace and path. Every so often, partners exchange, new rhythms arise, and the floor stays full without a single bump. Even the rings join the dance. Embedded moonlets lift streamers and traces. Distant shepherds tighten edges. Fine dust drifts inward like a slow snowfall. Material rains into the atmosphere in a hush. Beauty lives in the motion, not aside from it. These migrations soothe rather than startle. Whole eras of life on Earth rise and fall, while a Saturnian moon shifts by the subtlest degree. No rush, no urgency, only the clockwork of orbits and tides. The same gradual evolution that warms seas beneath ice may have tuned the planet's tilt, drawn shadows where clouds fold, set moons in resonances that later loosen, then knit new ones. Slide this forward far beyond our calendars, and the scene will have shifted again, rearranged by the same laws that made it. Hold, too, the paradox at the planet's heart. Saturn looks like a creature that shouldn't quite work. It's immense, yet startlingly light, a giant composed of hydrogen and helium, the universe's simplest breath. You'd expect bulk to mean density, presence to mean weight, but Saturn teaches a softer relation. It can be immense and gentle at once, powerful in gravity yet airy in composition, a lantern of gas holding a neighborhood together by poise rather than mass alone. Now look at the rings, the most famous contradiction of all. From far away they seem permanent, chiseled into the sky. Up close they are rafts of ice fragments, numberless and precise, their whole width spread thin as a paper laid over a field. They gleam like carved frost and endure not because they are solid, but because they are balanced. Motion and gravity knit them, Collisions soften their edges. Light makes them sing, and time slowly edits their script. They are fragile and persistent two truths that do not cancel each other, but define a particular kind of strength. The atmosphere wears its own double note. Pastel bands look sleepy, but winds beneath rush faster than almost anything at home. Storms the size of continents coil and linger. A six-sided jet at the pole holds its hexagon like a measured spell. No ruler, no architect. Only physics tracing a shape that feels too tidy to be natural until you understand the flow that draws it. Then come the moons, each adding a stanza. Titan sketches lakes and rivers and rain and methane, making landscapes that feel familiar through an alien chemistry. Enceladus, small and bright, hides a warm ocean beneath an ice crust and exhales plumes into space. Elsewhere, a world wears black and white, like a split mask. Another tumbles out of rhythm. A small sphere keeps a crater so large it remakes its face. The system reads like a notebook of experiments that happen to work unlikely, balanced, beautiful. Not one of these things breaks the rules. They only break our first impression of the rules. Understanding is the hinge that turns the impossible into the obvious. Saturn keeps teaching that contradiction is often only complexity we haven't learned to read. Lightness and strength, fragility and endurance, chaos and order. These aren't opposing teams here. They interlock. They complete the picture. The planet doesn't defy physics. It expresses physics with unusual grace. Let it be a small lesson for our expectations. We carry habits about what strength should look like, how stability must behave. Saturn hums another tune. Strength can be quiet. Longevity can arise from balance. Elegance can be an outcome of many small accommodations rather than a single force. The rings endure like frost that never hardens into a slab because countless pieces keep the pattern together. Moons trade energy and share warmth through a choreography that never needs a conductor. The giant itself, light in fabric yet mighty in influence, holds a system by gentleness and reach. Perhaps that is why this planet feels so comforting to look upon. It is rigorous and poetic in the same breath. The equations are there, humming, and the beauty is not an ornament, but a symptom of how well the system fits itself. The message that presses softly through is simple. The universe is not obliged to be simple for us, and yet it is generous with harmony. Let the contradictions rest together in your mind without friction. Saturn shouldn't exist if we insist on a narrower set of expectations. Instead, it does, gorgeously. Because nature can find delicate solutions. Because balance once found can last. Because complexity doesn't unravel when you hold it gently. Wonder lives just beyond the line where our first understanding ends. If a world can be so improbable and yet so coherent, what else might be quietly possible? The planet continues its long, unhurried orbit, wearing a crown that shines like frozen poetry, attended by moons that carry their own small stories through the dark. It remains a masterclass in equilibrium, immense and light, turbulent and serene, fragile and enduring. And it does not need to make sense at first glance to be real. It only needs to be itself. If the image lingers for you, let it do so softly. A calm lantern of gas, rings laid like silver breath, distant sunspark on the curve of a moon. Should your shoulders ease and your eyelids grow heavy, let that be part of the lesson too, that harmony can emerge from complexity, and that beauty can live where you least expected it. If you're still awake, still curious, the sky is wide with more quiet marvels, each waiting with its own rhythm and light. For now, rest. Somewhere far beyond the roof, Saturn keeps its slow waltz with the sun, and the universe keeps its gentle watch.